Okay, we're going to review several factoring concepts, and on the right there in green, I wrote down the steps to factor. So if that's something that you'd like to write down, you're welcome to do that. You're not required to do so. Get used to, and I know I've done it to some of you already, when you look at a problem and say, but I don't know where to begin, get used to me chanting, greatest common factor, greatest common factor. Because always, always, always in your mind, that's the first thing you should look for. Don't think about binomial, difference of squares, or trinomial, naming A, B, and C yet. Think about, do my terms of my polynomial have a common factor? That would be the number one thing that I think students struggle with, is searching for that greatest common factor first. So once we do the greatest common factor, we'll ask ourselves, do we have a binomial or a trinomial left? And then if we have a binomial, we'll look for a difference of squares. What that means is literally, do you have a difference, which means a subtraction problem, and two perfect squares with that difference in the middle? If you do not, then you cannot go further with a binomial. Then with the trinomial, here I put, is it in the right form, meaning ax squared plus bx plus c, where your middle exponent is half of your degree or your largest exponent. It would be okay to have a 4 here as long as you have a 2 here. It would be fine to have a 6 here as long as you have a 3. Also, it's okay to have an x squared here and a y squared here. You can have an x squared in the front and a y squared in the back, as long as in the middle you have an x to the first and a y to the first. You can have x to the fourth in the front, y to the fourth in the back, and in the middle, x to the second, y to the second, just like that problem that was on the board from one of those warm-ups a while ago. Okay, so let's just jump right in. Here's the problems. If you want to pause it and do them and then check them, whichever way you want to do this video is fine. I'm just going to run right through them. Okay, so number 1, greatest common factor. Yes, I have one. Both of these terms, these two terms, have x in common. I'm going to write down x. I'm going to divide both these terms by x and put the answer when I divide inside the parentheses. X squared divided by x is x. Negative 4x divided by x is negative 4. You could check each step as you go along to make sure you're correct. You could redistribute. X times x is x squared. X times negative 4 is negative 4x. So far I'm doing it correctly. Then is this a binomial or a trinomial? It is a binomial. So I'm checking for a difference of squares since it's a binomial. I do have a difference. I do have a perfect square. But this is not a perfect square. So that is my answer to number 1. I'm finished. Moving on to number 2. Looking at this problem, I do not have a greatest common factor. I have 1 x squared and negative 4. Numerically, 1 and negative 4 do not have anything in common besides 1. And variably, neither one of them both have a variable, so I do not have a greatest common factor. This is a binomial, so I'm looking for difference of squares again. Is this a difference of two perfect squares? Yes, it is. X squared is a perfect square, 4 is a perfect square, and I have a subtraction sign. One thing that I really think helps students make sense of this is, number 1, remember it always factors into two binomials, one with an addition sign or one with a subtraction sign, and you can interchange those, it doesn't matter. Take the square root, since you're talking about perfect squares, take the square root of x squared. That answer goes in the first spot of each of these. Then take the square root of 4. That answer goes in the second spot of each of these. I have had students ask me if I could treat this like a trinomial, although it's not a trinomial. Could I think of it this way? The answer is yes. This is in the correct form. A is 1, B is 0, C is negative 4, and you could find factors of A times C, which is negative 4, that give me a sum of B, and that would be negative 2 and positive 2. Those multiply to give me -4, and -2 plus 2 adds to give me 0. So either way you want to think about it is perfectly fine, totally up to you. But look, -2 and +2. So that is my final answer there. Number 3, do I have a greatest common factor? I have 1x squared, 5x, and 6, so no, I do not have a greatest common factor. Is this a binomial or a trinomial? Trinomial. And so I do have it in the correct form, ax squared plus bx plus c. This exponent is half of this one. So looking at it, I know a is 1, b is 5, c is 6. So I'll make a chart. There's so many different ways that you could do this to factor. I find factors of the product of a and c. So a times c is 6. And I'm looking for a sum of 5. And then I use my brain after that. When I first teach this to students, I tell them to write all the factors of 6. 1 times 6, 2 times 3. -1 times -6, -2 times -3. But if you use your brain, I want a positive product and a positive sum. So that should tell you that both your factors should be positive. So I know the only pair of factors that are both positive that I can multiply to get 6 and add and get 5 are 2 and 3. So that's what works. Since a is 1, I can go straight to my answer. I do have some students, we were talking about that this morning, I do have some students that do it a little bit longer, and I'll show you how in just a second. I put +2 and +3. And again, these are interchangeable. You could have x plus 3 and x plus 2. Quickly, I'll show you what we were talking about this morning. I have some students who take this, and what they do is they put 2 and 3 in place of 5x, and they factor by grouping. So they do x squared plus 2x plus 3x plus 6. You will find most college professors would probably prefer this method. I know here at our school, we have a pre-calculus calculus teacher who says that they would prefer this as opposed to doing bottoms up because students forget to do bottoms up. They'll just leave their answer like this and not do bottoms up. So you would group here. Take out a greatest common factor of x. Take out a greatest common factor of 3. And then you know it works when these two are the same, and they are. So I would take out their common factor, because this is a binomial, have one term and another term. Take out that common factor, and then multiply by what's left. When you take this common factor away, x is left. When you take this common factor away, 3 is left. So notice we got the same answer. So you're welcome to do it this way, which I call the longer way around, or the shorter way around. It doesn't matter to me, whatever you're more comfortable with. Okay, number 4. Do I have a common factor? No. Do I have a binomial or a trinomial? I have a binomial, good. Do I have a difference of squares? Yes, I do. So I automatically put 2 empty binomials, one with an addition sign, one with a subtraction sign. I take the square root of x squared, that gives me x. I take the square root of 121, that gives me 11, and I'm finished. Then students see this next one, they see this, and they automatically think difference of squares, well, it's not a difference, that's not a perfect square, so they're done. But they forgot greatest common factor. Do these two terms have a common factor? Yes, they have x in common. When I divide both of these by x, I'm left with x plus 12. Now, this is a binomial, but is this binomial a difference of squares? No, so I'm finished. That's my answer. Moving on to number 6. Do I have a common factor? No, I do not. I have a trinomial. That trinomial is in the correct form. And A is 1, B is -2, C is -15. A times C would be -15. Sum of B would be -2. Okay, so I needed a negative product. That means one of them's positive, one of them's negative. Thinking ahead even more, I need a negative sum. That means the bigger number is negative. So -5 times +3 multiplies to give me -15 and adds to give me -2. And then my A value is 1, so I can do this the quick way. X minus 5, X plus 3. And that one's done. Next, number 7. Do I have a common factor? Yes. They have 2 in common. So I'm going to factor out 2. And they don't have X, they just have 2. So I'm going to factor out 2. 2x squared divided by 2 is x squared. -32 divided by 2 is -16. Then is this a binomial or a trinomial? It's a binomial. Is it a difference of 2 perfect squares? Yes, it is. Don't forget to bring your 2 with you. Put 2 empty binomials, one with an addition sign, one with a subtraction sign. Take the square root of x squared, that's x. Take the square root of 16, and that's 4. Then, I do encourage students to check again for difference of squares. And this is a sum, so I know that's finished. But is this a difference of 2 perfect squares? It's a difference, and I do have 1 perfect square, but is this a perfect square? No. So this is my final answer to number 7. Number 8. Do I have a greatest common factor? Yes. And some students will say it's just 3. But don't they both have a variable in common? Yes, they both have x, so it's 3x. I'm going to divide 3x squared by 3x. What do I get when I divide 3x squared by 3x? It's just x. And then I'm going to divide -27x by 3x. What do I get when I divide -27x by 3x? -9. Then students think this is a difference of squares. What keeps this from being a difference of squares? The x isn't squared. So this is done. That one's finished. I can't do anything else with it. Number 9. Do I have a greatest common factor? I don't know why I didn't make sure one of these trinomials had a greatest common factor. Shame on me. But I don't have a greatest common factor. A is 1, B is 6, C is -7. Factors of A times C, sum of B. So -7 times 1 is not it. I didn't think ahead, I just started writing. I need a negative product and a positive sum, so the bigger number needs to be positive. This is the one that will give me a +6. I would put 2 empty parentheses, x in the first spot of each one, +7 minus 1. Okay, and then I'm going to skip down and do number 11. Do I have a greatest common factor? Yes, x is my greatest common factor. And when I factor out x, what's left? X minus 10. And is this a difference of squares? No. The other 2 problems, we will show you the answer in class, because I'm about out of time.